I want to find the area of these two parametric equations. X is negative 2 cotangent theta. Y is 2 sine squared. And we're given the interval from 0 to pi. I'm going to show you two ways to do this. One of the ways requires a lot of work, and the other way is very quick. So what you're tempted to do here is get it in terms of y and x, and the way to do that is to first solve for cotangent and sine squared. So first cotangent, we'll have to divide both sides by negative 2 to get x over negative 2. And then for sine squared, we're going to divide both sides by 2 to get y over 2. The goal here is to use the relationship of cotangent squared plus 1 is cosecant squared. So cotangent is x over negative 2. If I square that, I get x squared over 4. Now sine squared is y over 2. Cosecant squared is 1 over sine squared. So that's just going to be 2 over y. Now I can get a common denominator with x squared over 4 and 1. So that will just be 4 over 4, which will be x squared plus 4 over 4 is equal to 2 over y, which means flipping both sides. If I flip 2 over y, it becomes y over 2. Flip x squared up plus 4 over 4 becomes 4 over x squared plus 4. And now I could just solve for y by multiplying both sides by 2. So this is my equation now in terms of x and y. And here x is going to be all real numbers. Okay, so what that means is going from 0 to pi in this parametric equation is the same thing as x being negative infinity to positive infinity. Okay, so I can take the area underneath, or in that range, or that domain rather, from negative infinity to infinity, because these are all real numbers, of my function 8 over x squared plus 4. And this is a improper integral. So first I'm just going to ignore the infinities and just find the antiderivative of this thing. And for this you need to use trig substitution. Let x equal 2 times tangent. So dx is 2 secant squared. And actually, it's probably better to include them here because we're going to do a limit substitution. So as x approaches infinity, what is 2 tangent theta going to be approaching? Well, 2 tangent theta looks like this. Okay, something like this. So as this goes to infinity, theta would have to approach pi over 2 from the left. So think of it as just pi over 2. And as x approaches negative infinity, theta would have to approach negative pi over 2. So this would just go from negative pi over 2 to pi over 2. I would have 8 over x squared, which is just 4 tangent squared plus 1. Not plus 1. Sorry. 8 over 4 tangent squared plus 4, right, from this 4 over here. And then dx, I replace it with 2 secant squared theta d theta. Okay, now I can factor out a 4 in the denominator, and that just becomes tangent squared plus 1, which is actually secant squared. That's one of the Pythagorean trig identities. So that's just that's 4 times secant squared. I have 8 over 4. That's going to be 2. And then I'm going to multiply 2 by 2. to get 4 that comes outside. The secant squares are going to cancel. So I'm left with 4 times the integral from negative pi over 2 to pi over 2, 1 d theta. And that's the same thing as taking 4 and multiplying it by the length of the interval. That's going to be 4 times pi, which is 4 pi. So hopefully you realize that this is a lot of work, and hopefully there's a better way to do this. Okay, so it actually turns out that there is. Now let's look at a different approach that is much easier. This approach is taking the area from A to B, dx over d theta times y, and then d theta. This is the formula that we need. I don't have to rewrite this in terms of x and y. Okay, so let me remind you, x was negative 2 cotangent theta, y was 2 sine squared theta, and here theta is between 0 and pi. All right, now we can begin. So we just need to apply this formula. So the limits are going to be the same. We're going from 0 to pi. And then dx over d theta. So take the derivative of x here in terms of theta. That's just going to be 2 cosecant squared, because the derivative of cotangent is negative cosecant squared. And so you'll multiply that by negative 2 to get 2 cosecant squared. And then we have to multiply that by y to get 2 sine squared. Ooh, now cosecant squared and sine squared will cancel. We're just going to get 1. Now we have the integral from 0 to pi of 4 d theta, and that's just going to be 4 times pi. Notice we get the same exact answer, but look how much work we showed versus how much work we showed for the first approach.